My name is Erik Rasmussen, and I'm here today to talk to you about model-based testing using state machines. So the application that we're going to be testing is this autocomplete selector thing that you can, we've all seen 1,000 of these, where you type in your query, there's a little spinner while it's checking with the backend, and then you can arrow down or you can use the mouse to select the item, and then it gets set in the input. So how many of you write tests the way I do? I always sort of start like this, where first I stare at the spec file for a little while, and then I go to the website for the framework that I'm going to be using to do the test, and I go to the docs, and I go to writing tests, and how do we write tests with this framework, and that looks like a test there. I'm going to choose this one, and I'm going to go back over to my spec file and paste that in. Of course, this is not the test that I want to run, but I can change it to work with my application. So I'm going to set this to localhost 3001, and I'm going to set the title to what the title of my page is. And then I'm going to go over to the terminal and run it and see if it works. Great. Now, notice that it ran 3 tests, even though I only wrote 1. And that's because Playwright has this really cool feature that you can run your test in several different browsers. So for every one of my tests, I'm running them in Chromium, WebKit, and Firefox all at the same time. So if there's a browser-specific weirdness, which I think we've all run into at some point, it should catch those. But is this really working? You should always try and break one of your tests to make sure that you're actually testing what you think you are. And if we go and run it there, then excellent. It's broken, and also Playwright will open up this web interface that shows you a nice description of exactly what went wrong. So great, let's fix this. And now we're doing pretty well. Let's write another one. So what I inevitably do is I take the test that I already have, and I say, OK, let's test another thing. And I go and I do the way that we find an input on the page with Playwright is get by placeholder. That's where the placeholder that I've given it. And we're going to click on that, and then we're going to expect that it is focused. Copilot gave it a nice try, but it should be to be focused. And then I can come over to my terminal and run it, and notice now we have 6 tests that we're running, and awesome, it passed. So we're on a roll now. Let's add another one. This is, I'm feeling productive writing all my tests. So I copy the last one that I did, and I say, all right, let's see if it shows the spinner like it's supposed to. So I will type some value into my input using Playwright, and then I will check, is the spinner there? And I've given the spinner a role of status. Let's see if this works. So I run that. We're up to 9 tests now. Excellent. And awesome, that passes as well. So we are just killing it. Let's go for another one, right? So again, this is what I always do is I take the last one and let's do another thing. So let's check that we actually get the results being shown. I've given that a role of menu, and is that visible? And now we expect there to be 12 tests running. Excellent. And great, it works. Now, hopefully you're looking at this and you're concerned, like you would ask me questions about this PR, because we're duplicating code. Like you're not supposed to repeat yourself. You're not supposed to write the same code. And really, this final test is testing literally everything that the previous tests are testing. So why do I have so many tests? Like, it's sort of nice to get the thing that is broken as the description, but really, this is not good. So I know what you're thinking, but Erik, there's got to be a better way. So allow me to introduce you to model-based testing. Now, what is model-based testing? Well, I did some internet searching, and I came across this academic paper from 2018. And this is model-based testing. So thank you very much. No, just kidding. Let me see if I can explain it to you. Here, is that more clear? The idea is that you define all the possible states that your UI can be in. And this is not exactly the same as application state. This is UI state. This is what's on the screen. Is the dropdown open? Is the form field focused? Things like that. And then you can define all the ways that the user can get from one state to another. And you can't necessarily get from the first state to the last state. You have to go through a way to get there. And this is pretty simple to reason about. But what it allows is for the computer to then calculate all the paths through your application. And then it's just a matter of defining what are those interactions that get you between these different states. So the first one is a mouse click, and then you type something, and then you hit the down arrow, and that gets you to that final state. And then we can define those interactions for all of our state transitions. And it doesn't matter if there's a loop or something. It's not going to get stuck going up and down, up and down, up and down. So, okay, what do we need to accomplish this? Well, we need a way to simulate user interaction on our site and a way to represent a graph of states and transitions between them. So the first one's pretty easy because we have these nice frameworks like Playwright and Cypress and things that does exactly that. We can programmatically simulate a user using our web app. But how about managing states and transitions? Well, there's a state machine library called XState that I'm a big fan of that specializes in managing state transitions between different states. Normally it's application state, but they have this special version of the library called XState test that is built for doing exactly this. So let's do this. Let's convert what we've written so far into model-based testing. So this is what an XState state machine looks like. Normally you do create machine, but here we're doing create test machine, and then you define some TypeScript for your event types and your context, and you give it a schema that lets it better understand the types, and then you define your states here. And here we have one state called idle, and it's the initial state. And on the right, what we have is a visual editor. And the amazing thing about XState and what they've built at Stately, the company that creates this, is that it's bidirectionally synced. So if you make a change in the visual editor, which I'm about to do, it will write the code for you. And if you change the code, it will change the visual editor. So unlike every diagram you've ever drawn about your code, this actually does not go out of date. So let's define some state transitions. So we start with our idle state, and we load, and that takes us to the loaded state. And see how it's creating the code over there on the left. In fact, TypeScript is now unhappy. Imagine that. So let's make TypeScript happy. And then let's add another one. Let's say we click on search field. And that takes us to the search field should have focus. Okay, let's organize these a little bit better. And now TypeScript should be unhappy again because we added a new event. This is when you can make TypeScript happy, it makes the rest of your life easier. So now we've defined a couple of events, but we haven't written anything to actually test our application. So to do that, we go back over to our spec file, and we blow away all of this nonsense. And what we do is we do create test model, and we give it our model that we've defined in our model file. and then we get the paths through the model. And then for each one of the paths, we're going to call playwright's test and use the path.description as the description of our test. And then we're going to call path.test. That's an xstate test function. And we're going to give it state definitions and event definitions. And this is the basic scaffolding of how you do model-based testing with xstate test. So now we need to define some things. So we've got our, so this get paths thing here, that's what's doing all the heavy lifting. That's doing all the magic. It's looking at our model and figuring out all the different paths to run tests for. So let's define some things here. So states are things like loaded and search field has focus. And what we need to do here is to define the tests that the expectations, the assertions that we want to run when we are in those states. So when we're loaded, just like we had before, we're going to expect the page to have the title of model-based testing. And we need to use the expect from playwright. And when our search field has focus, we need to do like we were doing before. We need to select nice try Copilot. You know, it tries, right? We're going to get our search input again by placeholder, and we're going to be focused. Okay, so now we're testing that when we are in our state, our modeled UI state, that our UI is actually in that state. So now we need to describe how to get between states. So we do that with events. So this is not event like, it's not like the typical way you use the word event, but these are our transitions. So for load, we do exactly what we did from the code that we copied and pasted from the website. We're going to go to our local host. Thank you, Copilot, except it's 3001. And we're going to, click on search field. That's pretty easy too. Again, good try, Copilot. We're going to get our by placeholder our search and click on it. So now we've defined how we test each of our states. So we're going to start from idle, and when we load, we're going to run this. When we're in loaded, we're going to test this, and then when we click our search field, we're going to run this, and then when we get to search field has focus, we're going to test that, or assert that. Okay, I think we're ready to actually run this. Let's see what happens. So we run it, and we get some printouts from xstate test. I'm using the alpha version here. I think they've already silenced that. But good news, it ran one test 3 times for each of our browsers, and it passed. Now, this is really just the equivalent of our 4-line test from before, right? It's pretty simple, but by building it like this, it gives us the superpowers later to use our model to generate tests. So let's add some more events. We're going to type into our search thing, and that's going to bring us to searching. Now, when we type into our search, we're going to need to save the query that we run into our state machine's context. That's xstate terminology, but we're going to call an action called setQuery that's going to save that. And then we're going to transition to the first results should be highlighted. So it should show all the results. And this is not an event. This should always come after searching. So we can just define it like that, and then we're going to always transition into that state with no event happening. Okay, so let's add some more keyboardy stuff here. If we hit the down arrow, we're going to transition to, you guessed it, second result highlighted. And of course, we need to listen to the up arrow to go back. But we don't necessarily always want to go down with the down arrow, because what if there's only one result? Then you can't select the second one. So we can add what's called a guard in XState. So if we only have one result, then we're going to stay in the first result highlighted, else we're going to go down there. So if you've never coded visually like this, it's a little weird at first, but I think it's pretty easy to follow along what's happening here. Okay, so let's add typing. So if the first result is highlighted and we type a search again, then we should go back into searching and see the spinner again. So let's add that. We need to do the same set query. Let's copy and paste so we don't have to do that part again. And this shouldn't necessarily come from there, but if we have the second result highlighted and we type a search, then we should also go back to searching. Okay, so you can start to see how there's some looping and some paths and things going on here, where as the user interacts with the application, these are things that should work and happen. So let's go and appease the TypeScript gods, because as I was editing that, it was generating all this code for us. So let's add those events. 3 new events. Up arrow, down arrow, and type search. Okay, TypeScript is happy now. So let's go and implement those. So let's do the events first, because those are easy. As you might imagine, down arrow is just a matter of calling the appropriate playwright thing to press the down arrow key, which is page.keyboard.press. And this is down arrow, or no, arrow down. And obviously, up arrow is the same. Okay, so let's ignore the type search for the moment. Let's go to when we're searching, just like we did before, we're checking if the spinner is there. That was our status role, I believe. So we're going to expect page by role to be status and to be visible. Okay, so our next state is this first result highlighted, but how do we manage that? Well, we're going to have to we're going to need to be able to save our query into our context in our state machine, and our type search event has to have a query payload. Okay, and so now here, we need to be able to define how to inject payload into certain types of types, and we do that with a thing called event cases. So for the type of event called type search, here's an array of possible extra payload that we can provide to the event. And notice that's an array, so if we added more, then it would like branch and try all of them. So now we can do our type search event, and this is we get our event. That's how we're going to get our query payload. And we get the query out of it. And then we get by placeholder our search, and we are going to fill that with our query. Although TypeScript is a little bit confused because it doesn't quite know that that's the right kind of event. So we're going to do a little cast here and say it's an event that's type search. And we are still not right because event is a JavaScript global. Globals are always dangerous. OK, so now we have our query as a string, and we are filling our search field with it. So we're getting close. We need to implement our action and our guard. So the way we do that is just like in any other XState state machine, we add actions, and we're going to call our action setQuery, and this is using an XState thing called assign to update our context with the query that we get from our event. So we're going to ignore the context and get the event and event.query. OK, so now we need to define our guard. And the way you do the guard is you provide guards here. And our guard should autocomplete. So we need to return, given our context and the event that got us to our place, we need to give back a Boolean that is true when this guard is true. But how do we do that? How do we know what our results are? Well, we're going to have to define some expected results, right? So we're going to just create an object here that maps from our query to the results that we expect. So this is going to give back an array of Luke Skywalker. And we're going to do some TypeScript fancy stuff here and define a type that is a known query that's just the key of this. So that's only going to allow Luke as the search. And we can more strongly type these now because they're only ever going to be these keys. So now we can go down to our guard, and we can just say, if we have a query and expected results of that query dot length is 1, then we only have one result. And this needs to be a Boolean, so we're going to coerce that into a Boolean. OK, so we're doing pretty well here. We just need to implement these other states. So here, we're going to implement first result highlighted. And this is going to use our context. And our query is on our context. But we're going to need our expected results. So we're going to need to export this. OK, so now we can get our expected results from our query. Context.query. And let's go ahead and cast that. There's probably a better way, but. And now we have our known results. And we can find there should be something there should be a Luke Skywalker item on the page. So we can find that first result and not only check that it's visible, but also check that it has the right class. So it should have the class highlighted. OK, so that should do it. Let's do a little copy paste on our second one. And obviously, you wouldn't go and do third and fourth and fifth. This is just to confirm that up and down arrows do what they're supposed to. And TypeScript isn't happy there, but I'm not sure why. Okay, let's test this thing. So if we run this, it only ran 3 tests. Why is that? We have all these loops and things. Well, if we go and look, all it did was, you can read from this description, it queried with Luke, and then it loaded, and then it hit the down arrow. But it never hit the up arrow. Why is that? Well, that's because we have this guard here, and there was only ever one result, because we only simulated having one result. So what we need to do is go and add another line here with some more results, and then go over here to our thing that's going to test different possible queries, and add that there. So now, when we run it, look at that. It found 3 different paths through our thing. Let's see what those are. So you can see that it did skywalk, and then it went down and up, and another one it did skywalk, and then it queried Luke, and it's just testing all the possible ways that you can go through our application. So I think you get the idea of how we could build this out further, but in the interest of time, I'm going to stop there. So let me quickly recap what model-based testing gives you. You don't have to write the same expect assertions all the time. And yet they do run, because as you're going through the path, it is running those expects all the way. And as you improve your model, the tests write themselves. You get more and more tests. And it's easy to, when you're writing tests manually, to forget that there's a possible path through your application. But if your model is more or less sound, then it's going to test all the possible paths. I'm sure you've had a QA person that clicks on things that you would never have thought to click on, but it actually changes things. And what I really love about it is that it's really easy to reason locally about what to write the assertion on. You're in the state search field has focus, you know exactly what to write there. And same goes for implementing the transitions between states. This transition is called up arrow. Well, that's easy to write. And you get this lovely visual editor that helps you understand your model, but also helps you communicate with your team of, this is how we're modeling the UI for this page or whatever. Now, the negatives are learning XState in the visual editor. There is a learning curve there, but it seems, I don't know, it's very visual, and I think people could pick up on it. And I imagine your CI might get slow if you go from having your 15 manual tests to having 200 generated tests. It's going to take longer to run. But is that really a bad thing? I don't know. And it's a lot of fun. Speaking of fun, I quickly want to highlight one of my favorite features of Playwright. Normally, as we were running Playwright, it was running the stuff in a headless browser, where it's not actually showing the browser, drawing the browser. But there's a way to run Playwright as headed, and it's a lot of fun. It actually, you can see it doing all the things, going through all of the operations way faster than you could, obviously. And it sort of gives you this sense of security that, oh, it really is doing that. So quickly, let's look back at this scary chart from before. It's really not that scary. Obviously, you start with your spec, what your product manager tells you to build. And then you can actually do modeling and development potentially in parallel. Like, you could have a QA person draw up your model and while you're developing the actual code. And of course, you need constant communication during this process. But then you can generate these tests that run on your CI, but yet you can still write manual tests if you want to. And then you get this feedback, like for each PR, you could be told, hey, you broke something. And then the developers can still like run them locally if they want to. So my message to conclude is stop writing your tests manually. Model your app and let the tests write themselves. Thank you very much.